Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam FM on financial mathematics. Mr. Ronald Karkosik borrows 2,000 Polish złotys, PLN is the symbol for Polish złoty, at an effective rate of interest of 10% per annum and agrees to repay the loan with payments at the end of each year. And if you don't know, Polish złoty is the currency used in Poland. No, Poland has not adopted the euro. Poland has promised to adopt the euro as its currency eventually, and I think that around the year 6666 it will be a time to start thinking about it. The first payment is to be 400 Polish złotys, and each payment thereafter is to be 4% greater than the preceding payment, with a smaller final payment made 1 year after the last regular payment. Find that last smaller payment. And here's the solution. So Mr. Karkosik's payments will be 400, 1.04 times 400, 1.04 squared times 400, and so on. And the present value of payments made over n years, not including that last small payment, will be 400 over 1.1 plus 400 times 1.04 over 1.10 squared plus 400 times 1.04 squared divided by 1.10 cubed, and so on. And the very last one will be 400 times 1.04 to the power n minus 1 divided by 1.1 to the 10th. This is a partial sum of a geometric series, and its sum is equal to 400 times 1 minus 1.04 over 110, that's the ratio of that geometric series, to the power n over 0.10 minus 0.04. That's actually a version of partial dividend discount formula. Whatever way you look at it, that's the value. That's equal to 20,000 over 3 times 1 minus 1.04 over 1.10 to the nth. And let us find the values of n that the value of n that makes this equal to the amount of the loan. So this is equal to 2,000. And from this, 1 minus 1.04 over 1.1 to the nth is 0.3. Or 1.04 over 1.10 to the nth is 0.7, and then n has to be equal to natural logarithm of 0.7 over natural logarithm of 1.04 over 1.10. That's approximately 6.3590. Well, this means that there will be 6 regular payments. That's the 6 from the solution, and then one last smaller payment at time 7. The difference between the accumulated value of the loan at time 7 and the accumulated value of the payments made through time 6 will give us the amount of the last smaller payment. This amount, therefore, is 2,000 times 1.1 to the 7th minus 400 times 1.1 to the 6th plus 400 times 1.04 times 1.1 to the 5th, and so on. And the last one is 400 times 1.04 to the 5th times 1.1. And you can find this as a partial sum of a geometric series, or you can just calculate these because it's actually a relatively small number, 6 numbers. So whatever way you calculate it, this is approximately 184.99. That will be that last smaller payment. That's answer D. So this problem was created by me, and I own the copyright, and I also wrote the solution. I own the copyright. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.